Hello, and welcome to the fourth lecture in the OxRAM Robot Arm Software Lecture Series. And today we're going to be talking about ROS services. So, in this lecture, we're going to go over what ROS services are. We're going to learn how to define a new ROS service in our new package, and we're going to create our first ROS service client-server pair. Now, again, a reminder for the GitHub repository with these lecture slides and all of the example code that I make. So make sure you've got that on hand. Now, what are ROS services? It's a request response system. So the client node sends a request and awaits a response from a server node, which then listens to this request, processes it, and then sends a response back to the client when complete. Now, the request and the response are both ROS messages, and yeah, these are also ROS nodes, obviously, the server and the client themselves. Now, to illustrate this idea a bit more, we're going to revisit our square number factory, but we're now going to implement it as a ROS service. Okay, so the first thing we're going to want to do is we're going to define the service that we're going to want to use here. And so if we think, we're going to want our service to take as the request, the number to be squared, and as the response, it should be the squared number. So what we need to do is we first want to create this folder here. So I've already made it. So make a folder called SRV inside tutorial scripts. But it should be alongside scripts and SRC. It shouldn't be inside one of those. And what it's going to do is it's going to contain the definition for the service we're making. So also create a file called exampleservice.srv. This is going to be the actual definition for the service. So we can see here we've got our request, and we've defined an int32 to be our input number. So this is going to be the order. And then we do 3 hyphens, and this tells ROS the separation between the request and the response. So and here is the response. So and again, we're going to use an int32 here called output number. We can have an important thing to know is we can have more than one data structure for each of the requests and the response. So for example, we could have, say, a string or whatever that says, or like a float 64 maybe, or whatever that says, very high precision square number, even though they're integers anyway. So, but maybe if you aren't using integers, but you can define multiple input. You can define multiple entries in your request and multiple entries in your response. So you don't have to have just one piece of data that you're sending back and forth. You can actually have multiple. So yeah, but the important thing here is we've got our input number in the request and our output number in the response. Okay. So now what we want to do is, now that we've defined the service, we actually want our package to build it when we run catkin build. So what we first need to do is go into cmake.lists, and we first need to have a look here at this section. So around line 10, this define package, you'll need to add this line, message generation. So this is a new message that we're going to want to be adding, a new dependency that we're adding to our package, because we're going to need this package in order to generate to create this new service. So that's the first thing you'll need to do here. The next thing you'll need to do is go to around line 60, so about here, and you're going to want to uncomment this section, and make sure it looks like the following. So we want to add the example service.srv. So delete, so it will say like service 1, service 2, like it does in this other bits that's commented. Delete those. That's just an example of how you structure this. But we want to specifically add this service file. So this one that we've made here. So it has to be written exactly the same way. So example service.slv, and it will look for it in the service folder. And then we want to go down a little bit more to line 70. And we're going to go here to the generate messages, because this service that we're defining is really just a complicated message. It's a form of ROS message. So we're going to want to uncomment this, and it should look like this. So our dependencies should just be standard messages, because we're just using simple stuff. We're just using ints, int 32s in this case. You can define messages with more complicated data structures, but then you would need to have the appropriate dependencies here. So for example, you can have quite complicated messages called a pose message, but then you'd have to import the geometry messages package. But that would be for a more complicated application. But here we only need standard messages. And finally, we need to go to about line 100-ish, so around here, and you're going to want to uncomment Catkin package here, and then we're going to want the tutorial scripts libraries here. So once you want it to look like that, then Catkin depends on ROS.py and standard messages like that. And then we're also going to want depends on message runtime. And you need to make sure the brackets are there as well. By the way, there's in your VS Code or code editor, CMake lists and package.xml might not look as nice as this. So you'll need to download, it'll probably prompt you to download the extension for CMake lists, which I highly recommend you do. That's what it did when I first did this. So now that's all the changes that we need to make in our CMake lists. Both of these CMake lists and package.xml, they are the files that the Catkin uses to build the package, by the way. That's why we're editing these, because we're editing what Catkin is going to be doing when we run Catkin build, and we're making sure that it's actually going to build everything properly and that it's got the right dependencies to be able to do so. So we don't need to do as much here. So package.xml, we just need to go after this line. So after these depends, I've added a build depend message underscore generation. And then an exec depend on message runtime. No, they're actually, I'm seeing here that these exact same lines here. So if you want to, you can just uncomment that and that, but I've just put them here for clarity's sake. So yeah, make sure you've got the code, the line right, no typos or anything. So make sure you've saved it. So now we've edited these two build files, and we defined our service in that in this file in our new SRV folder that you want to make, our service folder. So now what you want to do is you want to go into terminal. So we can just go here, and then this will immediately take us into the tutorial workspace directory, because that's what we've defined as our what I've defined as my project directory in VS Code. And then I'm going to type, but you can also just do this in terminal, in a standard way, obviously. But we're just going to run catkin build. Good. It built very quickly because I already built in advance to make sure it was working, but it may take a few seconds. Cool. So now we've got our service defined, and we can start using it in the code that we make, which we're going to look at now. So if we go into scripts, lecture 4, just ignore lecture 5 and 6 content for now. We'll go into that in the future. So we're first going to have a look at the server, and let's see what's going on here. So we've got the shebang. We've got the import for ROS.py, because we're writing ROS code in Python, so you're always going to want that. And then we are also importing the important objects for the classes and stuff for our service that we've defined. So we're importing example service, the definition for it, and this example service response. Okay, so the way that the service server works when it receives a request is kind of similar to how a subscriber works, in that it does a callback. So this is actually the callback function here. We've defined a handle request. So the call requests are passed into it. So the request is the input argument here. And we're now, in this line, we're extracting the input number. We're just calling it X. But note how we're doing rec.input number, because service messages are more complicated structures than just, we can't just say X equals rec, because that it's the ROS message data structure has more going for it than just the actual data value that we've given it. So we actually have to extract. If we go back here, input number. See, so input number is a field in our message. So that's why we're extracting it. So we're doing rec dot input number, and then we're going to say what the order we received is. We're going to square it, and then we're going to say what the processed order is, and then we're going to return the example service response for x squared. So the client will be waiting for this response to happen once it's sent out the request. So it's there you go, and this is how we sort of circumvent having to have 3 different nodes and it going from like customer, factory, receiver. Now we've got client, server, back to client again. So init node, so initialize our node in the main body of the code, and then we're going to declare the new service. So we're actually saying our service is rospy.service. That's how you can. This is the constructor for service. So the name of this particular service is going to be example service, but you can actually name this whatever you want it to. But this is the type of service. So we could say example service 1, example service 2 here, example service 3. Maybe I should have actually done that. You know what? I'm actually going to do that just to prove a point. I'm just going to change this to example service 1, and I'll have to do the same with the client. Because the type of service is going to be example service, the one that we defined. And then the callback function is going to be handle request. And then it's just going to spin. So it's just going to wait for requests. And every time it gets a request, it's going to return a response. So meanwhile, the client here, we're importing ROSPy. We're importing random again because we want to generate the orders. Then we're again from our service folder in tutorial scripts, we're going to be importing our example service message type. So we're going to initialize the node. We're going to set our rate at which we're going to be generating orders, and then we're going to make a check that as long as we have that, we're going to make a check that we haven't killed the node, and as long as we haven't killed the node, we're going to be generating a constant stream of orders. So order is a random integer. Then we're going to say what the number is, and then we're going to wait for this example service to be online. So we're going to wait for the server to actually, what we should really do here is we say example service 1. So this is what I was talking about. You can actually have multiple channels. Like, if you want to use the example service, you can have multiple customers each talking to their own factories, so that you don't have crisscrossing. So you could, for a different client server pair, you could call this particular service example service 2 or whatever you want, but it would still be of type example service that we've defined in our SRV file. Hopefully that makes sense. But yeah, so you'll see how that works. So it's going to first wait for example service 1 to become available, which the server will set up. So you're going to want to run the server first, really, and then you load up the client, and the server should already be waiting. But this means that the client will wait until you have the server up before it starts doing anything. So that's what the purpose of this line is. So it doesn't just keep doing this without there actually being a server to respond to it. And then we've got a try except here, because the idea here is we're going to try to request. We're going to try and make a request. So we're going to say what our request is. And we're going to create a handle by which to call the service. So rospy.service proxy, and then to this particular example service 1, but it's of type example service. And then our receiver. So this is an interesting way of condensing our code. So we're defining what our handle is for making the request. And then we're going to say request, and then we're going to put in brackets order. So we're basically running a function. So we're going to say, so order is going to be our input to the request. So there's the input. This is the actual function that we're doing. So we're defining it in the line before. Now we're actually using it here, and then the server will, it will send out the request. The server will get that. The server will process, send it back, and then receiver will be what the response is. So note here that we're extracting. So when we say what the received number, the square number is, we're actually looking for receiver dot output number. So we're getting this entry here. They're extracting that value. And if the call fails for some reason, if something goes wrong, which it very well can do in a more complicated scenario, it's going to make an exception here and say that, if the try doesn't work, we're gonna put an error in the command line output and say that the service call failed for some reason, and then it will say what the error is here. So it's a string, and then that's the error. So the exception is E, and then we're going to sleep. So the idea is we're going to sleep according to the rate. So r.sleep means we're going to sleep for like half-second intervals, so 2 hertz refresh rate. So that's how those two are structured. Now let's see it in action. I'll do that in a sec. Okay, I've loaded up some terminals in Terminator, and now let's test out what we've made. So what we're going to do is we are going to I've already loaded up ROS core here, as you can see. So ROS core is already running. So it should be, you should know how to run ROS core at this point. Now what we're going to do is we're going to say ROS run. Obviously, you're going to have made permissions for your scripts to make sure that you can run them. So ROS run tutorial scripts, example service server. And it's going to do exactly nothing. Well, ostensibly, but it has actually set up the server, and it's now just waiting for some requests. So now we're going to do the client. So example service client. Okay, there you go. And look at that. And then ROS topic list. Let's just have a look. Okay, so ROS service list. There you go. Okay. So, as we can see, the client is generating numbers to be squared, and then every time it does that, the server receives that request and then squares the number. So number to be squared goes to order received, which then goes to processed order, which then it sends back to the client as a response. So the client now says number square number received, and then it says what the number is. So now we've got, rather than having to have 3 nodes, we've got the information going from the client to the service. So the client to the server, back to the client. And note here that although we're using the example service type, the particular name of the service that we've set up here is example service 1. So if we go ROS, actually, let's just see if this works. ROS service echo example service 1. This may not work. Yeah, no, that doesn't exist. I could do maybe ROS service info. There you go. Look at that. So you can see that the example service 1 uses the example service type, the example service server node, but it is an instance of the type of service that we've now set up. So yeah, there we go. That's a simple example of a ROS service server client pair. Okay, I think we can all agree that the ROS service approach is a much better solution to the square number factory, because we've now got a one-to-one back and forth two-way system, as opposed to the relatively messy approach of having to just use a simple publisher subscriber. Now we've only got two nodes, and that one client talks to the one server, which then the server talks back to that specific client. So yeah. Now, ROS services are great for when we know that the requested process is going to be fast. So, for example, when we're retrieving information about a robot's pose, or when we're spawning an object in a simulation, or squaring a number that I doubt in practice you'd ever want to use. But it's representative of maybe you're processing visual data. Maybe you send that off to a server to do separately to your client because your client's busy doing other stuff. So actually, it's probably not that much of a ridiculous scenario. But what about if we know that the process is going to take a while, like a few seconds rather than a few milliseconds? For example, if you're telling a robot arm to move to a specific pose, that's going to take a while. That could take a minute if it's quite a complicated set of maneuvers. In that case, you're going to want feedback. You're going to want to know how it's going. So in those cases, it's actually going to be better to use ROS actions, which we will learn about in the next lecture. So in summary for today, we had an overview for what ROS services are and how they work. We defined a new ROS service that we can use in our code, and we created our first ROS service client-server pair and tested it out. So your homework is going to be to revise, how ROS services work, go over the code, make sure you can understand it all. And next time, we'll be talking about ROS actions. So that's all for Lecture 4. I hope you enjoyed it. And I will see you in Lecture 5. Thank you for watching.